Hello, students. Once again, I welcome you all to the second lecture of the chapter of your grade 6, which is motion and measurement of distance. Okay, so in the previous lecture, we have already seen about measurements, that what is the need of measurement and what are the standard units of measurement. And then we have seen how to measure the length correctly, and then ended our topic with the measurement of a curved line, that is by a thread method. Now we are moving to the next part of this chapter, which is the motion or types of motion which we observe in day-to-day life. Okay, so let's start with the topic motion. Yeah, so now we are in this class concerned about motion only. We have done the talking about measurement. Now we are concerned about motion. Okay, so what topics we are going to cover here? We are going to cover this example of moving things around us, and another topic is types of motion. These two topics we are going to cover. Okay, so if I give you an example, suppose list all the objects you see in your day-to-day life around you. Suppose you can talk about school bag, you can talk about your car, you can talk about any bus, or you can talk about any chair, you can talk about any person who is sitting on a chair. So everything you can observe has some work or have something to do with that. Yeah, so just list the objects which are changing their position. Yeah, list the objects. Suppose if I am talking about your house, does your house change your position? No. Does the clock which is hang on the wall change its position? No. Yeah, if I talk about the school bag is changing its position. Why? Because you are taking it from your home to school and come back also to the home. Yeah, and if I talk about the cars moving on road, they are also moving. So you can list anything or every object around you. Some may be moving, some may not be moving. Okay, so we are now concerned with examples of moving things around us, but I have given you some list of things which are not moving, that is house, clock, road. You can take the example of road. Road is also a constant. Yeah, it is not moving. Road is not moving, you are moving on the road. Okay, so you can list numerous number of examples regarding this moving things around us. So first of all, see these pictures. What you are seeing, the picture on the left is showing a beautiful white pigeon who is just flying. So whenever any bird flies, it is just moving. You can simply say it is moving. And you can also observe that whenever birds are you observe in your sky, they are continuously moving or changing their place. Now the picture on the right is showing the motion of ant. The picture on the right is showing the motion of ant. So if I take this ant, particular ant, suppose I am taking this ant. So if I am tracing the motion of this single ant, you will trace the motion like this. If you carefully observe, you just take one ant out of these numerous ants and observe its motion. The motion will be like this, zigzag or something like that. So it is also changing its position. Yes or no? So these are the examples of moving things around us which constantly changes their position as the time progresses. Yes or no? You can see one example here also. You can see a clock here. Yeah, the second hand of a clock is moving continuously. Can you see? It is moving continuously like this. And in the right picture, you can see a rocket or a satellite which started its journey from Earth. Now started its journey from Earth, moved towards the another satellite or another moon, you can say, and then landed on the moon. So also it has changed its position with the time. Okay, so there are various objects around us which are changing their position with the time, or they are moving actually. They are moving actually. So that is something to do with the topic which we are going to study, which is known as motion. So how to define motion? If I say how to define motion, so if I'll simply say, if any body or any object is changing its position, any object is changing its position with time. So as the time progresses, if the object is changing its position with time, then that object is said to be in motion. Then that object is said to be in motion, basically. Okay, so whenever any object changes its position with respect to time, it is said to be in motion. Position can be changed by several ways. Suppose I am talking about a car. Suppose a car is moving on a road. Car is moving on a road. Suppose at a particular time it is at a position like this. So it is at a position A. Now after some time, as it is traveling towards right, it will be present somewhat here after some time. Yes or no? Suppose it is B. After another interval of time, it will be somewhat here. Yes or no? It will be somewhat here. So it is constantly changing its position with the time. So we will say the car is in motion. Okay. So if I talk about clock, does the clock changing its position? No. So we can't say the clock is in motion. We can't say the clock is in motion. So clock is not in motion because it is constantly hanging on the wall of your homes and it is not changing its position. But what about the seconds hand? If you carefully observe, seconds hand of the clock was moving like this. See, the seconds of the second hand of the clock is continuously changing the position. So we can also say this is doing some type of motion. This is also doing some kind of motion. So this is not necessary that for having motion, the body as a whole should move. The part of the body can also move. That will also be considered under motion. But yeah, the name will be different, which we will see later, that under types of motion. Okay, so now the thing is clear. If any object changes its position with respect to time, then that object is said to be in motion. So I think mostly things around us are in motion. Yeah, but you can list also the things which are not in motion, like house, road, clock. These are not in motion. Okay, now the thing is clear that when any body changes its position, it is said to be in motion. Done. Now we are going to see types of motion. We are going to see types of motion, that what are the different types of motion we can have. Okay, so there is a chart given here. You can see one is the rectilinear motion. Okay, we'll see in detail later. Second one is curvilinear motion. Third one is translatory motion. Another one is circulatory motion. This is oscillatory and this is periodic motion. Okay, so basically main types of motion which we are concerned with is the rectilinear one. This one is circular one, and the third one is periodic. So these are the three important topics we are going to study: rectilinear, periodic, and circular motion. Okay, now we'll see what are the properties involved in different types of motion. Okay, so can you see this curvilinear motion also? This curvilinear motion is made up of two words: curve plus linear. And this rectilinear is made from the word linear. So linear means, so what do you mean by linear? Linear means in a straight line. Linear means in a straight line. So whenever motion is present in a straight line, that is known as rectilinear motion. And what is curvilinear? Curve plus linear. Matlab it has two components. It has two components. One is linear, that is straight line, and one is curve. So it is doing two types of motion: moving along a curve as well as moving straight. That is known as curvilinear motion. But we are not concerned about this. We have to focus on rectilinear, circular, and periodic motion. Clear? Now see, first of all, rectilinear motion. So rectilinear motion, as I already defined, is made from the word line. Line means in a straight line. So motion in a straight line is called rectilinear motion. Okay. So suppose I have already given you the example of the car. Car is moving on a straight road. Suppose car is moving on a straight road. So it is performing a motion which is known as rectilinear motion. Okay. This is known as rectilinear motion. Done. So you can see the examples of rectilinear motion in day-to-day life. The car on a straight road, it is moving in a straight line. March past of soldiers in a parade, they are again doing a straight line motion, that is known as rectilinear motion. Water falling from a height, yeah, it is also moving along a straight line like this. So it is also example of rectilinear motion. You can also take the example, suppose you are standing on a building. You are standing on a building, or you are just dropped a ball. You have just dropped a ball or a stone from this height. So what will be the motion of this stone? It will fall on a straight line like this and ultimately reach the ground. Yes or no? So this motion of stone is also example of rectilinear motion. So whenever motion is present in a straight line, it is considered under rectilinear motion. So I hope this is clear. Okay. So the next concept is circular motion. Next concept is circular motion. So what is circular motion now, or what is the basic difference between circular motion? If I give you the example of a fan like this, the fan is, blades of a fan are moving. Yes or no? If I talk about this fan as a whole, this fan as a whole is not moving. Yes or no? The fan as a whole is not moving. But yeah, if you see the blades, or if you mark a point of this blade, suppose I am marking this point, and I'm observing this point. So I'll observe that this point is rotating like this. It is moving in this type of path. So this type of path is known as circular motion. So what is the basic property of circular motion? If you carefully observe, if I redraw this diagram, so what you will observe carefully, suppose I'm redrawing this. Okay, so suppose I have marked a point on the blade of the fan and it is doing a motion like this. So what you can see, its distance from the fixed point, which is the axle of the fan, is constant everywhere. Its distance from a fixed point, which is axle of the fan in this case, is constant. Yeah. So whenever an object performs motion such that its position from a fixed point remains same, then that type of motion is considered as circular motion. Getting my point? So what is the circular motion? You can see in a circular motion, an object moves such that its distance from a fixed point remains the same. So whenever the distance of an object from a fixed point remains the same and it is doing some kind of motion, then that will be considered under circular motion. Getting my point? Okay. Now the second example you can see is a giant wheel moving. I think all of you have enjoyed this ride in your childhood days. Yes. Some of you might enjoying this right now also. Yeah. So this is giant wheel moving. So this is another example of circular motion. You can see this is the center point. From this center point, if you take this wagon, so this wagon is performing a motion in the circle like this. And you can see the distance of this wagon from this axle is always constant at every point. Whatever point you are taking, it is always constant. So this type of motion is also considered under circular motion. Now what about this third type of motion, which is movement of the planets around the sun? This you can't observe easily. Yeah? This we can't observe easily, obviously, because this is space related issues. Yeah. So movement of the planets around the sun is also example of circular motion, in which sun is at the center. Sun is at the centers and planets are revolving around the sun in circular orbits or kind of circular orbits. Such like that their distance from the sun is constant every time during their revolution around the sun. So that's why we are considering it as a circular motion. So what is circular motion? If you have to define that, in circular motion or in any motion, if the distance of that object is constant from a fixed point, then that type of motion is known as circular motion. If I talk about the second hand of a clock, which you were observing there, if I take back you here, in this case, now you can see this clock was, second hand of a clock was also moving. So if I mark a point here right now, so this point will be moving like this. This point will be moving like this during the entire journey of the second hand clock. So you will see its distance from the center of the clock is also constant at every point. So that's why it can be also considered as a circular motion. So I think that difference is clear. What is rectilinear motion? What is circular motion? In rectilinear motion, particle or object moves in a straight line, and in circular motion, it moves such that its distance from a fixed point remains the same. Clear? Now talking about the third type of motion, which is periodic motion. Okay. Now, if I give you one example of circular motion from daily life, it can be like that. If I tie a stone with a thread, this is a stone. So if I tie this stone with a thread and I whirl it with my hand like this. So whatever motion this stone is performing is the circular motion, because you can see the distance of the stone from the center of the thread is constant everywhere. So you can say it is performing a motion which is circular motion. But what if I hang this thread from my hand and the stone is here? Now what I'll do, I'll push this stone somewhere here and just drop it. I'll push this stone somewhere here and just drop it. So what will be the motion of the stone now? The motion of the stone will be like this. Yeah, the motion of the stone will be like this. Yes or no? It will do a motion like this. Getting my point? So this type of motion can't be considered under circular motion. This type of motion can be considered under periodic motion. So what is the basic property in periodic motion? That the motion is repeating itself. Motion is repeating itself. If you can see the example of pendulum, the setup which I have explained to you is known as pendulum. When you are hanging a thread and from thread a stone has been hanged. So whenever you are moving it like this, this is basically repeating its motion. Yes or no? This is basically repeating its motion again and again. So that type of motion which repeat itself after a certain period of time is called periodic motion. It is written already here. Motion that repeats itself after a period of time is called periodic motion. I think this is clear. So this is the example motion of a pendulum. I think you all have seen this vintage clock. This is the hand of a clock which moves in this motion like this. First it goes here, come back here, then go towards the right like this. So it is basically repeating its motion. So that's why it is considered under periodic motion. Another example of periodic motion can be a motion of a child on a swing. What is the motion on the swing? It will go upward, come back to the ground, and go backward. So it will be like this. So this type of motion is repeating itself on a swing. So that's why it is considered as a periodic motion again. Now talking about the third example, which is branch of a tree moving to and fro. So if you see during windy days or whenever wind is blowing, the branch of a tree glows like this. Due to the wind, it will move forward, come backward, move forward, come backward, move forward, come backward. So this is again repeating its motion. So that will also be considered under periodic motion. So we have considered three types of motion basically. First is rectilinear, means in a straight line. Circular means whenever the distance of a point from a fixed point is constant, then that is considered under circular motion. Third one we have covered is periodic motion. In periodic motion, motion repeat itself after a certain period of time. That is known as periodic motion. Is this clear? Okay, so I hope this is clear. Now there is one motion also which is known as rotational motion. So what is the basic difference between rotational motion and circular motion? Rotational motion versus circular motion. So if I take the example of a fan, these are the blades of an electric fan which are moving. So if I take a point on this fan here, so you will see when the fan is moving, this point is moving like this. So if we are considering this point only or any point on the blades of the plane, then that will be doing a motion known as circular motion. But as a whole, if I take this fan as a whole body, so this complete fan is not rotating along any point. Yes or no? This whole fan is not moving along a fixed point, or I can say its distance from a fixed point is not constant. So the motion of the complete fan is known as rotational motion, and the motion of any part of the blade or any point of the blade is known as circular motion. So if you consider any part of the body, that will be considered in the circular motion. Yes or no? And if you are acting, or if you are considering the complete body, then that will be covered under rotational motion. So the basic difference is clear between rotation and circular. So now there can be some cases where an object can undergo more than one type of motion at the same time. The types of motion we have studied, there can be some objects which can perform the multiple types of motion at the same time. Now see the example of a ball rolling on the ground. This ball is rolling on the ground. So how the ball will roll? Ball will roll like this. Will do this type of motion like this. And it will also move straight. Yes or no? So basically this is a combination of two types of motion. One is the circular motion, or you can say rotational motion if you are taking the ball as a whole body. So it is a combination of rotational or circular motion as well as rectilinear motion. Yes or no? Because the ball is also moving in a straight line. So that is the component of rectilinear motion, and it also rotating like this. So this can be taken as a circular motion if you are considering one particle of the ball, and this can be taken as a rotational motion if you are taking the ball as a complete body. Clear? Now the second example of the multiple motions is the sewing machine. I think you all have seen in your homes sewing machine. So sewing machine has two types of motion. One is you are moving it with your hands like this. So when you move it like this, what is happening? Any part on this wheel is moving in a circular motion like this. But yeah, when you are moving it, the needle of the sewing machine goes up, down, up, down, up, down, up, down, which is used to stitch the cloths. So the needle is somewhere here. So the needle goes up, down, up, down, up, down continuously when you move the wheel of the sewing machine. So that the wheel is doing circular motion, and that needle is doing motion which is known as periodic motion. Periodic motion, because that motion is repeating itself after a certain interval of time. Up, down, up, down, up, down. So that is the combination of circular as well as periodic motion. So you can see here also a ball rolling on ground. A ball rolling on ground shows both rotational, or you can say circular, as well as rectilinear motion. Then, and a sewing machine remains at the same location while its wheel moves with a circular motion. The wheel of the sewing machine is moving with a circular motion, and it also has a needle somewhere here that moves up and down, undergoing a periodic motion. So these are some of the examples where multiple type of motion can be present at the same times. So we have differentiate between rectilinear motion, circular motion, or you can say rotational motion also if you are considering the body as a whole, and the periodic motion which repeats itself after a certain interval of time. Okay, so I think we have get the basic concept of all the types of motion. Yeah, now we will see the motions in much detail, or you can get a better feeling after watching these videos. Okay, so I'm showing you some videos to get a better view of the motion. Let's one second.
Ben wants to move this table from point A to point B. What will he do? Yes, he will push it in a direction of point B.
What this boy wants to do, boy wants to push the table from A to B. So what he will do, he will push it towards right to get to the point.
As he pushes the table, it starts moving. Anything around us that moves, we say that it's in motion.
So now what you see, while he was trying to take the table from A to B, he is just pushing the table and the table was moving. So anything that is moving is in motion. So we can say the table along with the boy, both are in motion because both are changing their position actually.
The table is in motion. And since Ben is also moving along with the table, he is also in motion. In our day-to-day life, we see various things moving around us.
So in our day-to-day life, we have already seen various moving things around us that can move.
That I can give are vehicles moving on the road, people walking across streets, birds flying in the sky, and so on.
So these are some basic examples: cars running on road, people walking on road, birds flying. These are the examples of moving things around us. That I was saying that the about the sun or around the sun, planets undergo revolution.
One thing about the sun, you can live with thousands of such challenges. What if I ask you to tell me the definition of motion? How can we
Now he is asking about the definition of motion, that how can you define the motion? So how we define motion? Whenever the object changes its position with the time, then it is said to be in motion.
Something as intuitive as motion of a body. Well, for that, we need to look at what exactly happens to a body when it's in motion. Let's say this vehicle moves from point A to point B. Yes.
So this car is moving from point A to point B. Let's see what happens.
As it's moving towards B, its position in space changes with time. Initially, it was here, then here, and now after some time, it's here.
Now you can see the position of the car is changing with time. So we can say it is in motion. Yes or no?
Notice what's changing. The position of the object and the time too, which is changing everywhere. The changing position of the car with time is what we call motion.
So now see, change in position of any body with time is known as motion. So I hope it is now much more clear.
Whenever there's a change in position of a body, we say it's either underground motion or underground motion. Let's discuss about the different types of motion.
Now we are discussing about types of motion we have already done.
Motion is called the rectilinear motion. Notice that there is a word line in there. So we define this type of motion as a motion in a straight line.
So motion in a straight line is known as rectilinear motion, as it can be seen from the word linear or line.
Yes, rectilinear motion is nothing but motion in a straight line. So if an object is moving along this straight line path, we say that it's performing rectilinear motion.
Yeah, that is clear. Now if any object moves in a straight line path, that is said to be in rectilinear motion.
For example, when a car is moving in a straight line on a straight road, it's performing rectilinear motion. There is one more thing that I want to discuss with you in this video. Assume you're on a railway platform watching the...
Okay, so this is the basic example of rectilinear motion we have given. So we are now seeing another type of motion in the next video. Yeah, now this is the second type of motion.
In the previous video, we studied what motion is. We also saw one type of motion called the rectilinear motion.
So we have already seen what is motion and what is the rectilinear motion. Yeah, we have already seen that.
It's nothing but straight line motion. In this type of motion, the path of a moving object is a straight line.
Yeah, you know, in rectilinear motion, obviously the path of the object is in a straight line because motion in a straight line is defined as rectilinear motion.
The path of a moving object is circular? Yes, you guessed it correctly. If an object is moving in circles, it's undergoing circular motion.
Now you can see this car is now moving in a circular track, so that's why now its motion name changes to circular motion because it is moving about a certain fixed point in a circle or along the circumference of the circle.
As the motion of an object around the circumference of a circle. The circumference of a circle is the length of this boundary which is curved. So if an object is moving along the circumference of a circle, we say it's undergoing circular motion.
Clear? Now if any object moves along the circumference of a circle, then it is said to be in circular motion. Or other definition, that if it is moving from a fixed distance or the distance of this point is fixed from a particular fixed point, then it is said to be in circular motion again.
Motion?
Yes, we can give.
What about the satellites orbiting the Earth? Yes, a satellite orbiting at a certain height is also undergoing circular motion.
You can observe also this satellite is moving around the Earth. So Earth is a fixed point from which the distance of the satellite is constant and it is moving along the circumference of this circle of its orbit. Yeah, so that's why it is also performing circular motion.
What are the examples of circular motion can you think of? Take a small object and tie it to one end of the road. Take the other end of the rope in your hand and whirl it around in circles.
You can see the motion of this object which is whirling around is in a circle only, if you can imagine. The fixed point is at the center and it is moving in a circular motion.
That the object is performing circular motion. Notice that the distance of the stone from your hand is always the same. What about the moving fan?
This was the third example, moving fan, which is also performing circular motion.
Is it also undergoing circular motion? First, let's only consider the motion of the point on one of its blades. If you switch on the fan, you will see the point moving in circles. So we can say that the blades of the fan are also undergoing circular motion.
Now you can see if we have marked one point on the fan, then that point is moving in a circular direction. So it is performing circular motion basically.
Now what if I take the fan as a one single object? Can I say that the fan as a whole is moving in circles?
Now yeah, if you have taken the fan as a whole single object, now can you say the fan is moving in circles? Obviously no, the fan is not moving as a complete body. Only the part of the fan which we have marked on the blade is moving in a circular motion. But as the complete fan, it is not moving.
Circumference of a circle. But which motion is it performing then?
Yeah, now which motion it's performing because it is not moving along the circumference of any circle as a whole body. So that motion is known as rotational motion if you are taking the body as a whole.
Undergoing rotational motion. Before actually defining this type of motion, let's try to understand it first.
Okay, now I think this type of motion is clear. Yeah, rotational motion is also clear to you. Yeah, so I hope we have covered all the basic types of motion needed for you, that are rectilinear motion, means motion in a straight line. Second one was circular motion, motion along the circumference of a circle, or you can say that if the position of a body from a fixed point remains constant, then that type of motion is known as circular motion. Third one was the periodic motion, in which the body repeats its motion after certain interval of time. We see it in the second hand of a pendulum of a clock. Yeah, swing of a swing of a child. Yeah, moving to and fro, and the branches of a tree moving to and fro with the wind. Yeah, and that's the last example we see was the rotational motion. If you are taking the body as a whole, then that type of motion is known as rotational motion. So I hope that this concept is clear, that what is motion, change in position of any object with time, what are the different types of motion. We have already seen that in detail. So I hope it is clear. Now you can also categorize after the class, perform one activity, then try to list the objects around you, that which are moving, which are not moving. So you will be able to identify which objects are in motion, which objects are not in motion. The objects which are moving with time are in motion and the other ones are not in motion. So do that activity after the class. So I hope all the concepts I teached in the class are clear to you. So thank you so much. Stay safe and enjoy. Yeah, but remember one thing, if you get any type of doubt after this class or at any point of time, you can refer to the forum at the Ask IITians website. You can post your doubts there and you will get the answer to your doubts there. Okay. So thank you so much. Bye.